Okay, so for example number 7, there's an airplane flying. Perfectly drawn airplane. Okay. And here I am, laying on the ground, looking up at it with my eyeball.
You're upside down.
No, I'm laying down on the ground.
You're supposed to flip the other way?
How would I be able to see it if I'm flipped the other way? This is my head right here.
Yeah. So you're rolling your eyes back to look at the airplane.
I'm laying on my back like this.
Oh.
Anyways, the point is that I'm pretty close to the ground. All right.
Are you live streaming this on Twitch?
Yes, I'm live streaming on Twitch. No, I'm not live streaming on Twitch. But here's what I know. Here's what I know, you guys, that this angle is 30 degrees. All right. I also happen to know that the airplane I think we did that last problem wrong. Anyways, we'll come back to that and think about that. I also know that the height, the airplane is flying at 5,000 feet. So just to kind of recap your memories, this triangle here, this perfectly drawn triangle, is a right triangle. This is 90 degrees. If this is 30 degrees, then what is this angle here? 60, because they have to be complementary. So we're going to say complementary angles alpha plus beta equals 90. And one other vocabulary term that I kind of mentioned, but I don't know if we have it written down in our notebooks. Supplementary. I think that's an E. I can't remember. Means that alpha plus beta equal 180 degrees. Okay. So then the ratios for this triangle should be the shortest side, which is across from the 30-degree angle. That should be 1 times x. The hypotenuse should be 2 times x. Okay? And then the remaining side would be square root of 3 times x. So if this angle here is 30 degrees and the plane is 5,000 feet, I know immediately that 1 times x equals 5,000, or x equals 5,000, right? What's the length right here of the hypotenuse? 10,000. How did you get that? So remember, the ratio is 2x, so this is going to be 2 times 5,000 feet, which is equal to 10,000 feet. So from me laying down on the ground looking up, the airplane at that instant in time is 10,000 feet away from me. About 2 miles, almost 2 miles. All right, what about the distance of where I'm laying with respect to being right above the plane? In other words, what's this distance here, from here to here? Well, that's the square root of 3 times x. We know that x is equal to 5,000, so we say the square root of 3 times 5,000. And again, we're going to use our fancy calculator. Guess what? I got it. Square root of 3 times 5,000. Whoops, I got to put the multiplication number thingy there. Symbol. I've been doing math all day. Leave me alone. 8660, and we'll say 25. Well, yeah. Now we'll just round to the nearest foot.
Mine's an error.
Yours said error?
Yeah, and I typed it in right.
Bring your calculator here, let me see. Now whenever we round something, oh, because you had the multiple, you gotta hit the right cursor to get out.
I did.
No, you didn't.
For real?
Yeah, you're in denial.
Swear?
I promise you.
Hold on, give me a sec. Let me cook.
Whenever we round a decimal, remember you gotta do the approximate symbols, which is like the squiggly line. It's called a double tilde. Did you figure it out?
Yeah.
Okay. So let me show you that too, because that might become an issue. So whenever you take the square root of something, the calculator will put everything under the square root until you push yourself out of the square root. So what you want to do to take the square root of 3 times something, to get out from under the square root symbol, the radical symbol. Oops. Now I'm in like, you got to hit the right cursor twice. Then you hit times, then you hit 5,000. His error was, he did it right, kinda, but when he hit this, he had this. And the calculator just doesn't know how to do that. Okay? So that'll come up again, probably. No big deal. All right. Does that help going over this example?
Yeah.
Okay. So I'll post that in Canvas.